Hi again guys, welcome back. This is video number 4 and we're talking about finding scale of a drawing for a view. Let's say we want to put a view on a drawing sheet and that sheet size is, for example, D size, which is 22 by 34. We want to put the view here and we want to know that what's going to be the scale for that view. Or to be more precise, we want to know the architectural scale for that drawing. And we know that architectural scales are a fractional number equal to 1 foot 0 inches. We want to find that fractional number. For this one, I'm going to go back to lab 1. I'm going to do this one with you because as I noticed, some of you guys had some questions and some concerns regarding this scale factor. And because we're going to repeat the same topic in lab 2 and lab 3 too, I want to make sure that none of you guys have any problems. Okay, so this is lab 1 result. And have a look at the building size. It's 32 feet by 22 feet. That's a big building. And this is my frame, or sometimes we call it title block. But title block is just this portion of the drawing frame. But people call usually this one title block too. So if I bring the title block here, that's a D size title block or D size drawing frame. And that's 22 by 34 inches. And compare it to the building. This is the building size, and this is the drawing size. So I have two solutions. One solution is that I scale this one down and I put it on the drawing sheet. Another solution was that I enlarge the frame and put it around the view. In old days, the second solution was the only solution that we had, because till maybe about 10 years ago, we didn't have layout. But recently, not that recently, but Autodesk added this feature to AutoCAD, which is layout. So here, I show you the result of the layout. But as I mentioned this one to you before too, we gonna learn this one in CAD290. Okay, so this is the view and this is the frame. This sheet is exactly 22 by 34. So from here to here is 34, from here to here is 22. And I have adjusted this one here. You can see that it's 34 by 22. Okay, and this is the view. If I double click on them here, we call it viewport, you will see the scale here. My scale is 1/2 inch is equal to 1 foot 0 inches. So that's the scale of my drawing here. Architectural scale of my drawing. So basically it means that I reduced and shrink the view to fit it on a 22 inches by 34 inches sheet. In this video, I'm going to show you the other method. And the other method was putting the frame around the drawing. There are some advantages here too. Just imagine if this is my frame. It's here. Let's just accept this. This is my frame, and I want to shrink this and put it here. In AutoCAD, when we draw a building, when we design something, we go with a scale of 1:1 or full scale. So everything here is full scale. So I don't want to shrink this one and putting it here. Because if I do that, every time I have to remember that how much I shrink this one. So I'm doing it the other way around. I enlarge the frame and I put it around the view. The view, the drawing that we have here is 22 height, 34 width. Let's have a look at layout again. This one was 34, this one was 22. But look at this one, not the entire area is used for this view. So for example, from here to here is 22, but look at this, from this point to this point is probably around 15. From here to here is 34, the width of the page, but from this point to this point is probably around 20. So what this tells you? This tells you that when you want to scale down a drawing, leave some spaces on the sheet. These spaces are for title block, for the drawing frame, or sometimes we want to add some notes here. We want to put a table here. You have something else to put around the view. So how to manage this? This is the thing that this is what Tim did in his video, and I'm gonna do something similar here to show you what happened in the video. What we do, we use the rectangle to put a rectangle around the view. You can do it by typing REC, and here, because I cannot type with my keyboard right now, I'm gonna go with this icon, which is rectangle, and I click on this point and this point here. Roughly, I draw a rectangle around the view. Now I draw a line from here to here. What else we did? He enlarged this one, this block, 1.5 times. So he made it larger. How much? 50% larger. You may ask, why 50% larger? It's because of this one. Look at this. This is the block that we have. And if you make it 50% larger, it's going to be this block here. So that's for the area that I need, the white area that I need for the future, or for the text, or something that may come here around the view. So let's go back to model space, and this is the block that represents the view. And what Tim did, he wanted to enlarge basically this block. So he selects this line and then scales this one. You can use Command 2, and this is the base point for this one, and 1.5 times larger. So this is going to be the new rectangle, new block around this. So now let's go back to view layout. I want to show you what happened. That one is around here. Right now you cannot see it, but it's around here. see it? So basically that new block is this one. Okay, but don't forget, this was the second solution that you're gonna learn it in CAD390. Okay, what we wanted to do, we wanted to put this frame around here, and I want to know that how many times I have to enlarge this to go to exactly here. So I want to have this title block or frame the way that the title block, the writing is gonna go here, and the frame goes from here to here. Okay, so what else he did? He measured from here to here and here to here, and he knows that this is 34 and this is 22. What this tells you? Do you remember from previous video? This is the something that we want to enlarge it to this. So if I divide this by this, I can find the inverse scale factor. And by multiplying this one by that number, I can put this one around here. But the problem is that this block that you see here is not the same as this one. So basically, if you even shrink this one, maybe you could fit the height, but the width might be different. So what we're gonna do, we're gonna go with the one that we're gonna try this one 2 times. We're gonna divide the height by the height that we have here. We're gonna divide width by the width that we have here, and then we're gonna compare it. I had to stop the video because the length of my videos should be less than 15 minutes. And what I did here, I just put the dimensions here. So I want to find the ratio between this and this, and ratio of this one to this one. And don't forget something here. This is the sheet that we have. This is the frame that we have. It's 34 by 22. But in reality, just 28 of that 34 is usable because we have title block here. And 21 of that 22 is usable because we need some area around the frame, around the here. So I'm going to go here. I just created a picture for this one. This way we have this one. So we're going to do the calculation here, very, very simple calculation. 28 divided by 699 and 21 divided by 561. So from this calculation, from this one, you can find 0.04, and this one gives you 0.037. It's like 40 and 37. So which one is larger? This one is larger. So for a scale factor that we need here is 0.0400 or something close to that. Why pick the larger one? Because just imagine if you scale this one more, scale it down more, there's more chance that you can fit it here, right? But if you go with a smaller number, probably a little bit of this one gonna stick out. Okay, so I found the scale factor, but it's not architectural a scale factor. So I have to do that one. So in my next video, I'm gonna do that. So please bear with me and watch the next video, and we're gonna be